Okay, so now we're going to talk about radical equations. And the word radical, that just means root. So for example, the square root, the cubed root, the fourth root, we're going to be dealing with equations that have roots in them, or radicals. First example that we have is solving the square root of 2x plus 4 equals 4. Couple things you want to notice. Before you can actually solve it, you have to make sure the radical is by itself, which means it's isolated on one side of the equal sign, like we have here. Once we have that, it's quite simple. You would just need to eliminate the radical. So in this case, I'm going to raise both sides of this equation to the power of 2, and that could eliminate the square root. That's the idea here. So what happens next is the square root squared goes away because it was isolated, and I get 2x plus 4 equals, and 4 squared is 16. And then we can go ahead and solve that. Pretty simple. So we get 2x equals 12, x equals 6. And then always make sure you go back and check your work for these ones. You want to make sure you can check your work. Of course, that can get a little bit more difficult, so let's do another example. Let's do square root of x minus 1 plus 4 equals 7. Same idea, you still want to be able to square both sides, but just make sure you're careful. You can't square both sides of that equal sign until you've gotten it all, the radical isolated all by itself on one side of that equal sign. So, sorry about that. Next thing what we're gonna do is then subtract 4 from both sides, because that will make it so we have the radical now isolated on one side of that equal sign. And that was the goal there, was to get that isolated on one side of the equal sign. Once you have that, then you can square both sides. And that'll eliminate the radical. So I square both sides. And then you can continue to solve, and then I ended up with x equals 10. Make sure you always go back and check that in the original to make sure that your answer is correct. And that's how we do that. Now, of course, we can have other types of radicals. So what if I were to have, let's say, the cubed root of x plus 1 equals 2. How do I get rid of the radical here? Well, now it's no longer a square root, it's a cubed root. So the same idea, you make sure the radical is isolated, but now I'm going to raise both sides to the power of 3, and that's what's going to eliminate that radical. So I raise both sides to the power of 3, and I end up with x plus 1 on this side equals, and 2 cubed, 2 times 2 times 2, that's what that means by the 2 cubed. 2 times 2 times 2 is 8. And then you're going to end up with x equals 7. And the same thing, go back and plug it in at the original to check to make sure it's right. Ta-da! Okay, so let's do one that's a little bit trickier. Still the same concept. We still need to first isolate the radical. So I'm going to go ahead and add x to both sides here. And the reason we're adding x to both sides is, as you'll notice, this x right here is not underneath the radical. So it's not attached to it. So I need to move that to the other side so that we can get our radical isolated. Alright, and then we'll see what we end up with that. You'll end up with the square root. Now I have x plus 2 equals, now 2 plus x, you could write that as x plus 2 if you would like, and that's fine. And then you're going to go ahead and square both sides. So then I can go ahead and raise both sides to the power of 2 and see what happens there. And the reason is now I end up without the radical, so I have an x plus 2 on this side. But on the other side, I have x plus 2, that whole quantity is squared. Now that quantity squared is the same thing as writing it as x plus 2 times x plus 2. So you will in fact have to go ahead and multiply that out. Then you'll end up with x plus 2 equals x squared plus 4x plus 4 after I've already combined my like terms. And then here what we have now is what we have a quadratic equation. So we have a quadratic equation, and we know there's a couple of ways for us to solve that quadratic equation. We could use the quadratic formula, and in order to do that you have to have 0 by itself first. So I'm going to go ahead and isolate 0 really quick so we can see if that's going to work. Get everything else on the other side. Okay, so now I've ended up with 0 equals x squared plus 3x plus 2. I ran out of space, let me rewrite that over here. X squared plus 3x plus 2. Now you could do the quadratic formula, or what's easier is you could try to factor it. Alright, now that you have 0 by itself, in this case that factored into an x plus 2 and an x plus 1. Yep, the 2 times the 1 will give me the 2, and the 2 plus the 1 will give me the 3. So that's how that factored. So I ended up with two solutions. I have x equals negative 2 and x equals negative 1. So how do I know which ones are the correct answer? So you always have to go back, and I'm going to write this here to remind you, you have to go back and check in the original. Okay, check which ones worked. And so you plug in that negative 2 and that negative 1 in for both of these guys, and you'll end up, let's see, negative 2, negative 1, you'll end up with both of them working. So in this particular example, they do both work. Sometimes one of them will work, sometimes none of them will work, sometimes both of them will work. So you always have to go back and check your work at the very beginning. And that's how we solve these radical equations. Ta-da!